Welcome to setting up a RESTful API for CRUD. After watching this video, you will be able to explain representational state transfer, or REST architecture principles, and their role in create, read, update, and delete or CRUD operations. Develop a RESTful API using Spring Boot, Java Persistence API or JPA, and MySQL. Implement input validation, error handling, structured responses, and advanced data retrieval techniques, and test API endpoints using client URL or curl commands and logging techniques. Every time you order food, book a ride, or stream a video, an API processes your request behind the scenes. Many of these APIs handle data transactions smoothly using REST architecture. A RESTful API follows the representational state transfer, or REST, architecture to design web services. It allows client applications, such as web browsers or mobile apps, to communicate with a server using HTTP methods such as GET, POST, PUT, and DELETE. RESTful APIs handle data transactions efficiently, making them widely used in modern applications. CRUD operations form the foundation of most applications. Applications rely on these CRUD operations to manage data for user accounts, product catalogs, or inventory systems. REST APIs provide a standardized way to interact with databases. They allow applications to perform CRUD operations efficiently and consistently. Spring Boot abstracts away a lot of the legwork you have to do to create RESTful APIs, and therefore can really help speed up the process. It provides the @REST controller annotation to define API endpoints, integrates with the JPA to interact with databases without raw SQL queries, and includes built-in request validation to ensure data integrity. This video will guide you through building a RESTful API for managing books, connecting it to a MySQL database, and testing it using curl commands. Serialization converts Java objects into JSON, allowing them to be transmitted as API responses over the network. Spring Boot automatically handles this process using the Jackson JSON library. Instead of returning raw objects, wrapping responses in a structured format improves consistency. The API response class includes 3 key fields. The status field indicates whether the request was successful. The message field provides a short description of the outcome. The data field contains the actual response payload. The controller method modifies API responses to follow this structure. If a book is found, the API returns a successful response. If not, it returns a structured error response. This approach ensures consistency and improves front-end handling. HTTP headers add extra details to API requests and responses. Request headers help clients communicate with APIs by specifying what they expect. The accept header tells the server to return data in a specific format, such as JSON, while the authorization header includes authentication credentials. Response headers describe the return data. The content type header informs the client about the format of the response, ensuring proper data interpretation. HTTP status codes indicate the outcome of an API request and help clients understand the response. A 200 OK status confirms a successful request, while a 201 created status indicates that a new resource was added. Client-side errors include 400 bad request, which means the input is invalid, and 401 unauthorized, which requires authentication. A 403 forbidden status blocks access to restricted resources, while 404 not found indicates that the requested resource does not exist. Server-side errors include 500 internal server error, which signals an issue on the server. Using the correct status codes improves API usability and ensures clear communication between clients and servers. This example shows how to return a 201 created status when adding a new book. The responseentity.status HTTP status.created method sets the status code, and the API response object structures the response. Use clear and meaningful resource names in REST APIs. Endpoints should represent resources, not actions. Use HTTP methods to perform CRUD operations. Get retrieves data, post creates new data, put updates existing data, and delete removes data. Use pagination to limit the number of records in API responses. This improves performance and prevents large data loads. The controller method retrieves paged results using a pageable parameter. In this code snippet, the endpoint is /paged. When somebody makes a call to this endpoint, they can pass in certain parameters. In this example, we are passing in page 0, which is the first page. We are passing in a size of 5, so we only want 5 books returned in the response, and we want the results sorted by title in ascending order. Logging helps monitor API activity and debug issues. Spring Boot includes a built-in logging system that uses SLF4J and Logback. Logs track API usage, detect errors, and help debug production issues. Enable SQL query logging to track database interactions. Adding this property to application.properties displays raw SQL queries. Use logging in controllers to track API activity. The logger logs messages when endpoints are accessed. In this code snippet, the import command imports the logger. The logger factory class is used with getLogger to create the logger instance, and logger.info is used to log the fetched information. curl commands help test API endpoints directly from the command line. They allow sending requests and viewing responses without a front-end application. The following examples show how to retrieve all books and add a new book using curl. Use a GET request to retrieve all books from the database. The API returns a list of books in JSON format. Use a POST request to add a new book. The request must include a JSON payload with book details. The API validates the input before storing the book in the database. In this code snippet, curl is using the POST method. The -h flag sets the header. The content type is specified. The -d flag is used to pass the data, and the URL is the endpoint that is being created. In this video, you learned that a RESTful API follows the REST architecture to design web services. RESTful API allows client applications such as web browsers or mobile apps to communicate with a server using HTTP methods such as GET, POST, PUT, and DELETE. REST APIs provide a standardized way to interact with databases, and they allow applications to perform CRUD operations efficiently and consistently. Spring Boot provides the at-rest controller annotation to define API endpoints, integrates with the JPA to interact with databases without raw SQL queries, and includes built-in request validation to ensure data integrity. Serialization converts Java objects into JSON, allowing them to be transmitted as API responses over the network. HTTP headers add extra details to API requests and responses. HTTP status codes indicate the outcome of an API request and help clients understand the response. Best practices for RESTful API design include using clear and descriptive resource names in REST APIs, using HTTP methods to perform CRUD operations, and using pagination to limit the number of records in API responses. And enabling logging and debugging can help monitor API activity and resolve issues.